Here we're solving a rational equation. Rational equation is just an equation that has two rational expressions. And if you have only one fraction per side or one rational expression per side, it's probably best just to cross multiply. Okay, so I'm going to multiply opposite corners. 3 times x plus 2 equals 11 times x minus 3. And we're going to distribute 3x plus 6, 11x minus 33. Okay. And just continue this off. Okay. So we'll leave it 39/8 is equal to x. Okay, so if I went to and put this back into x in each of these positions, I would end up with 32 or 39/8. So sometimes you may get a fraction, other times you won't, but that's a linear look to a rational equation. But sometimes you get a quadratic look, right? So when we cross multiply here, we have a resulting quadratic equation. Multiply here, multiply here. Okay. And remember, when we have a quadratic equation, you want to get everything to one side generally. Okay, we can't isolate x squared because x would be in the way. So it would be best just to bring this 30 over. Okay. Now we want to factor it. So what are numbers that multiply to give you negative 72 but add to give you 1? Well, that would be plus 9 and negative 8. Okay, so x plus 9 and x minus 8. Now you set each of these equal to 0. And you solve. Now you do have to be careful here. Sometimes you get what we call an extraneous solution, which is a solution of a simplified equation that does not actually solve the original equation. But here, the only excluded value would be negative 7. So these are both okay. X equals negative 9, and x equals 8. Sometimes you're going to have a rational equation with 3 or more expressions. And here cross multiplying won't work unless you were to combine these two. But we're not going to combine these two. It's probably better instead to multiply everything by the LCD. Okay, so we'll do that here. That requires me to factor. Okay. Now the LCD, remember the product over GCF formula. That's only good when you have exactly two things you're finding the LCD of. All right, so if you wanted to find the LCD of 2 at a time and then take the result and find the LCD of that, you could. But here it's best just to look at, just inspect it. And the LCD is going to be everything that you see there. And we see an x minus 5, we see an x minus 1. On all three denominators, we have no more than one x minus 5 and one x minus 1. So my LCD is exactly that, x minus 5 times x minus 1. Okay, so I'm going to, in this case, instead of cross multiplying, what we're going to do is multiply all three of these by that LCD. Okay, here's what it's going to look like. Now, 24 okay, so I multiply that times that fraction, and then 6 and 2. All right. And by multiplying all three of these by the LCD, you're guaranteed to eliminate every denominator. Crosses out here, crosses out there, crosses out there. Right? And what that leaves us with, I'll write it down here. It leaves us with 24. And then we're going to distribute and distribute here. Okay. Now I'm going to finish this on another board. Okay, so let's do that. So there's that equation. All right, so we'll combine like terms. (24) and 30 become 54. Get x to one side. And eventually we'll get x equals 7. Make sure that this is not at an excluded value. Okay, and it's fine. 7 would not make any of that become 0. All right, I'll cut my light off here. All right, this last bit here talks about vertical asymptotes and holes in the graph. So let's look at the difference there. Vertical asymptotes is just what makes the bottom 0. Very similar to excluded values. There is a difference that we'll talk about. But what makes the bottom 0 here, we don't really even need to do this. We can just say it's x equals -6. And that's it. That's a vertical asymptote. Hole in the graph is a little different. This one doesn't have a hole in the graph. Okay, the hole in the graph occurs when we have a canceled factor. Okay, so if you'll notice here, the x equals -3 will be a vertical asymptote. Okay, that one is a vertical asymptote. The x minus 3, though, is a cancel factor. So x equals 3 would be what you would call a excluded value, but it's not a vertical asymptote. If it gets canceled, as a hole in the graph. Okay, so what I would do then, so I know over here, x plus 3 equals 0. All right, that's where that came from. Okay, if I set x minus 3 equals 0, that one, it's a hole in the graph. To get the y coordinate, you take 3 and you plug it in here and here. Okay, so if I put a 3 in for both, that's going to be -4/6, and -4/6 is -2/3. So vertical asymptote are things on the bottom that are not canceled that set equal to 0. Holes in the graph are things that are canceled to get the x, and then put it back into this to get your y value. Okay, vertical asymptotes versus holes in the